The second experiment in chapter 21 is the preparation of ethyne gas and to examine its properties. Ethyne is prepared in a very similar way to ethene, which we studied recently. We are going to react two substances together, and we are going to collect the ethyne gas over water in the very same way we did with ethene. The reaction here, however, does have an extra step in the middle, so there is one slight difference. So we're reacting calcium carbide with water, which is going to form our ethyne gas, the C2H2 here, and it's also going to form calcium hydroxide. That's fine. The calcium carbide, however, is very impure. It's usually contaminated with calcium sulfide, calcium phosphide, and calcium nitride. So it has other substances mixed in with it that are very hard to remove before the experiment. So what we do is we react the impure calcium carbide with water to allow this reaction to happen. But other substances are going to be formed as well. So it's not just going to be these two substances in the reaction. So what we need to do is we need to remove those other products before we can collect the pure ethyne gas. How we do that is before collecting the gas over water, we insert another piece of apparatus in the middle of the experiment where the products from the reaction are bubbled through a solution of copper sulfate, where the other impurities are removed and pure ethyne can be isolated. Let's discuss that looking at the diagram so you can actually see what would be happening. So in the Buchner flask, the conical flask with an extra little bit out here, we've got the calcium carbide in there, and we're going to be adding the water in slowly and carefully from a dropping funnel, because we don't want to add it too quickly, because that will cause a very rapid production of our products, and we would get impurities in our final product then. So what you're going to do is you're going to slowly open the tap here on the funnel, and you're going to add in water drop by drop. And what you'll notice is down where the calcium carbide is, you'll notice some fizzing and a white solid being formed. And that white solid is the calcium hydroxide from our balanced equation. So the calcium carbide is a black color, and it will start turning white as calcium hydroxide is formed. Calcium hydroxide is another name for a lime scale that you might see on the inside of your kettle. We will be forming calcium hydroxide, and we'll also be forming the gases. So we're going to be producing ethyne, which we want, but we'll also have those other impurities reacting with the water, giving us products that we don't want. So now we're going to move on to step 2, which is the gases transferring over into the acidified copper sulfate solution. And all those impurities are going to be removed here. They will dissolve into the copper sulfate solution. So that's where we're going to leave them. And then ethyne won't dissolve in the copper sulfate solution. Ethyne will be transferred through the delivery tube and collected over the water over here on the right. So your key things to note here is that you have fizzing and a white powder being produced in the bottom of your flask, the white powder being the calcium hydroxide from your balanced equation. You're adding the water in slowly so as not to produce too much gas at the beginning. The acidified copper sulfate solution removes the impurities, and the ethyne, pure ethyne, is collected over water over on the right. You also do need to know how to write the balanced equation for this. So this is a quick snippet of the video of the guys in UCC doing the experiment. You can see here we've got the blackish grey calcium carbide. The water is up above it that's going to be dropped in slowly. We've got the blue acidified copper sulfate solution that the gas is going to be bubbled through first to remove the impurities. And over here you'll see some bubbles appearing in the trough as well, as that's where the ethyne gas is going to be collected over water. They haven't got a gas jar there yet to collect the gas because this is the very beginning of the experiment. And remember, the same for Ethyne, we don't collect or don't use the first bit of gas that's produced, because that is just the gas, the air that's inside in the apparatus being pushed out. So that wouldn't be pure ethyne either. So let's have a look at the experiment. So you'll see him dropping in the water, and you can see the bubbles forming there as the gas is going through the acidified copper sulfate solution. I'll play it again. And you can see some bubbles being formed over in the water trough as well, where your gas would be produced. Once the ethyne has been collected, we are then going to examine the properties. So the properties are quite similar to the properties of Ethyne. It's a colourless gas, has a sweet smell, it's insoluble in water because ethyne is non-polar and water is polar. However, it is soluble in organic solvents because they are also non-polar. So we are going to watch this clip of the combustion of ethyne and try to remember back for a second what you saw with Ethyne, because you're always asked to compare these two. So Ethyne was a bright luminous yellow flame, and just have a look at the ethyne combustion here. You can see when it starts that it's a bright luminous flame again, but it's very sooty. It produces a lot of soot. So we have a luminous yellow flame again, it's smoky. There's lots of soot formed, and you could test the gas that's produced here and your lime water would turn milky, because like I said last time, any organic substance that you're given, if you were asked to write an equation for combustion is when it reacts with oxygen, you're always going to produce carbon dioxide gas. So the lime water would always turn milky. The next property we're going to look at is saturation, and there's not much to say on this because if you've learned learned the information for Ethyne, it's the exact same for ethyne. Ethyne is also unsaturated because it has a triple bond. So if you add bromine or bromine water, the bromine water will change colour from red or brown, you could say, to colourless. And if you add acidified potassium permanganate, the solution will turn from pink or purple to colourless as well. So the exact same procedure and the exact same results as we had for Ethyne before. So before we go on to the properties, just to mention again about the tests for unsaturation, the reaction of ethyne and bromine water or with acidified potassium permanganate are identical to those of Ethyne, and this is due to the fact that both of them are unsaturated. They have a double or a triple bond in the molecule. So the first question you could be asked here is explain why the first few test tubes of gas are discarded. We covered this in the Ethyne video. It's because they mainly contain the air that's being displaced or pushed out of the apparatus. It wouldn't, the gas would be air rather than Ethyne or ethyne. That should say ethyne on this slide. Describe the procedure and observations during the combustion. So you would do it in a fume cupboard because it's so smoky. You would use a lighted taper or splint at the mouth of the test tube or gas jar like the last time. It burns with a bright luminous flame. It's extremely smoky and lots of soot is formed. The soot is a result of unburnt carbon. So this is something we didn't cover earlier on that I want to say now. So all of that soot is black carbon. If we were to burn all of the ethyne molecules in the gas jar that we saw earlier, you would need loads of oxygen, and obviously there's only a small amount of oxygen able to get into the gas jar because it's filled with ethyne gas. So the complete combustion of the entire gas jar doesn't take place. So we have some unburnt carbon that's going to be left over. We're not going to burn all of this carbon. As you can see, for 2 molecules of ethyne, you would need 5 molecules of oxygen, which we just don't have in that small space of the gas jar. If this question comes up, it does tend to be worth a good few marks, and it tends to be comparing the combustion of ethene and ethyne. So these two experiments tend to be mingled together in an experiment question. Last question is to give a major use of ethyne. The main one is that ethyne is used in torches for welding. So they're oxyacetylene flames or torches. It's also used to make ethanol, which is another organic substance that we'll see in chapter 22. It's used to make polymers, plastics and pesticides, and it used to be one of the main fuels for lamps, street lamps and things. You can't just say fuel on its own, because it definitely wouldn't be used as a fuel for cars or trucks, for example. You would have to specify that it's for fuels for lamps. And that's the end of this experiment.